We are doing October November 25 paper 4.3. So the question 2 says that a program reads the string data from a text file into a linear queue, then compresses the data. So we have the source file as well. This is the source file we have, so it has multiple ones and zeros. Okay. Then the question says that the queue can store up to 100 elements. The 1D array will be called queue, and each element is to be initialized to empty string. Then we have the queue head that points to the index of the first element in the queue, and then queue points to the index of the last element in the queue. Okay, so example, let's say we have the queue array here, and it stores values like 12, 14, 16, 18. So head will be pointing to the first value, whereas tail will be pointing to the last value in the queue, and it would not be pointing to the next available space, as is the case in some questions. Okay, so this is very important to know because we have to update the pointers accordingly. So they're saying the global variable number item stores the number of items in the queue, initialize to 0, write the code to declare and initialize all of this. Okay, so we just have to create queue head and tail. So queue will initially be empty. Then we have queue head will be set to -1. Then queue tail is set to -1, and the number of items are set to 0. And then we are supposed to run a loop. So for I in range, and we are supposed to put 100 empty values in it. So we'll say queue dot append empty string, and we can just print the value of queue for now, and it should print 100 empty values, and it does. So this is the first part. Okay, in part B, they're saying write the function enqueue, which will take a string as a parameter. The function checks if the queue is full and returns false if the queue is full. Otherwise, you will update the number of items and you will put the value in the queue. Okay, simple enough. You just have to write the typical enqueue function, define enqueue, and we're going to pass in a parameter string value. So let's call it item, and then we will global all the values. So global number items, queue head, queue tail, and then global the queue as well. Okay, then we are supposed to check if the queue is full. Okay, so in order to make sure that the queue is full, we just check for the number of items in the queue. The queue is set to 100 values, so we can just check it against the number of items. So if the number of items in the queue become greater than 100, then that means that we're going to return false because there is not enough space in the queue, elif, or we can simply say else. Okay, so elif, we have to check if the queue head is initially equal to -1. Okay, the question says that the head is initialized to -1. That means initially it is set to -1 here like this. So when we add a value, let's say the queue was initially all empty spaces, and when we add a value here, the head is also supposed to point to this value now instead of -1. So we have to keep this thing in mind when the queue is empty. So if the queue head is already equal to -1, so that means the queue is entirely empty. So what we have to do is we have to place the value, and we have to move the value of the head to 0. So if queue head is equal to -1, then we have to simply update the queue head to 0 because we're going to place a value here. Once this is done, then we are just going to in else, or regardless of this, we are just going to update the values. So we'll say that so first of all, since the tail is pointing to the last value, we are going to increment the value of the tail, and then we're going to store the value. So I'll say queue tail plus equal to 1, right? Because if it is pointing to 18, we cannot store at 18, we'll store at the next space then. So whatever the next space is, we'll move the tail to there, and then we'll store the value. So queue tail plus equal to 1. Then I'm going to store the value here. I'll say current queue tail would store the value of head, value of item. Then we do number of items plus equal to 1 because we have added a new value, and we simply return true. So in this case, what will happen is whenever we add an item, so if the number of items are already 100, then already greater than 100, we return false. If the head was already set to -1, which means the queue was entirely empty, we set the head to 0. And if neither of these conditions are true, we simply just increment the queue tail by 1 and we put the value, increment the number of items, and we return true. So this is what you have to do. Then they're saying write the function dq. So we can hide this part. They're saying write the function dq. So dq, and they are saying that in the dq part, we are supposed to remove the value from the queue. So if the queue is not empty, the function will return the next element in the queue. Okay, so let's say if the head is pointing at 12. So what it will do is it will return 12 and it will point to the next value, which is 14. So it will go to the next index. So we have to global the values, global the queue head, the queue tail. Let's do it in one line. Queue head, queue tail, and then we have the number of items, and we also have the queue. Okay, then we have to check if the number of items is equal to 0, then we simply return false, because that means that the queue is empty. And if that is not the case, so what we're going to do is we are going to first of all get the value that is currently at pointed to by head index, by the head pointer. So I'll say, let's call it deleted is equal to
Uh,
queue. So deleted is equal to, we get the value from the queue head and we go to that index. So let's say the head was right now pointing at 14. So 14 will be deleted from the queue. Then we increment the value of queue head by 1. So head will move to the next value, which is 16. And then I'm going to reduce the number of items by -1 because we have reduced one item, and then I return deleted. The reason I do not return deleted before is after the return keyword, no function will work, no code will work. So if I write return above, so this code becomes unreachable. You can see the code color changes as well. So it will always be the last line, and then it will return the value, and this the part C is done. In part D, they're saying binary data stores individual binary digits 1, 0, each digit is on a new line. For example, the first line stores 1 and then 0. Okay, so these are all binary bits. Then they're saying the procedure read data reads in each line from the file and inserts it into the queue using the appropriate method. The procedure needs to work for a text file with any number of lines up to a maximum of 100. So write code for read data. Okay, again, a simple question of file handling. So read data, no parameters needed, and then we have to simply open the file. So f is equal to open. The file name is binary data.txt. We're opening it in read mode. And then for line in f, we are simply going to strip the line and then we're going to enqueue it. So enqueue the item. Let's call it item as well because we called the parameter item, or if you call it line, it's still the same thing. Then we have to first strip it so it removes the white spaces, and then we are going to get the response from enqueue, because if we remember, enqueue is supposed to either return true or false depending on the logic. So then we check if at any point response becomes equal to false. That means that the queue is full now, so we will just simply break the loop, and that is what we have to do. The procedure needs to work for any number of lines. Okay, and then at the end we need to close the file as well. So the question says that we have the maximum limit of 100, so maybe we can put this in
like a while loop.
so we'll use a for loop. So for I in range 100, because we are setting a limit, and then this would be, we'll have to read the line. So item is equal to f dot read line. So this will read one line, and then we'll say item dot strip, and everything remains the same. So this will run for 100 times fixed now. So if we call the read data and we print the value of the queue, so it should have all the values here, and it does. It gets all the 24, 25 lines from the file, and then the remaining values would be empty because there's nothing in there yet. Okay, now the question says, so we'll hide this part. The question says the string data in the text file is compressed. The compression algorithm counts the number of times each digit appears consecutively, then stores the binary digit followed by the number of times it appears. The algorithm stores the string data in a single string. For example, the text file contains the data. So 1, 2, 0, 3, because there are two 1 digits followed by 0, 3, 0 digits. Okay, so 1 is appearing twice. So then we write 1 and then we write 2 next to it. Then since there is no more 1, we count for zeros. So 0 appears 3 times, so we write 0 and we write 3. Then 1 appeared 3 times again, so we write 1 and 3 again. And that is what we have to do. So the question says we have to use the dequeue method to remove each element from the queue. The procedure then compresses the data using the string. The new string is then stored in the global variable called new string. You can assume that only one digit will never appear more than 9 times consecutively in a sequence. You can assume there will always be at least one item in the queue. Okay, so what we have to do now here is we have to come up with some mechanism where we are storing the values. We are first of all popping the values, and we have some sort of check where we're checking if the value is repeating. So we read the current value, this is 1, and then we start checking if the next value is also equal to the same value. If they are the same, we keep on dequeuing and we keep on incrementing the count. If the next value, so let's say the current value is 1 and the next value we dequeue is 0, since they both do not match, that means that the value is not being repeated, so we move on to the next digit, so on and so forth. So we keep on flipping between 1 and 0. In order to do this question for compress, what we have here is the dummy data in the queue from the file that we had. So what we're essentially doing is we are comparing the current value with the next value, and as long as the current value is matching with the next value, we will keep on incrementing the count. So let's write these steps as well. So what we're going to do is we're going to compare the current value with next, and as long as if they match, so we are going to increment the count by 1. So we'll do count plus plus. Okay, otherwise if they do not match, then what we have to do is we are simply going to append the new string is equal to new string. So in the new string we are going to add our current value, and we are going to simply add the count with it, right? So if the new string is, let's say it's maybe 1 so far, so, or if it was 1 1, so if we encounter a 0, that means, so like we had 3 1s here, let's see. So when we encounter a 0, since these values do not match, what we're going to do is we are going to, in the new string, we are going to add a current value. So the current value is whatever the value is going to be, we'll pick that, and then we are going to append a count into it. So the count so far is 3, so it would become, in fact this should be not triple one, this should be 1, and then we simply add 3 next to it. So what you're doing is that we have the new string here. Let's say it's initially empty, it's a global variable. And then what we're doing here is that if the current value does not match with the next value that we have, so let's say this is empty, and we're going to append the current value, which is 1, and we're going to append the count into it. So the count so far is 3. So the new string becomes 1 and 3. So in quotation marks, this becomes 1 3. Okay, now next time the loop starts again. So we compared the current value with the next value. So this is the 1 here, and this 0 does not match, right? So we had already exited this condition. Then again, we go to the next one. So we compare the current 0 with the next 0. Since they both match, I'm simply going to just increment the count of these zeros by 1. So count becomes 1, then it becomes 2. Okay, then next time we compare the current 0 with the next one. Since these values do not match, again what will happen is in the new string I'm going to, so the new string is so far 1 3, right? Okay, I'll just write in the next line. So new string is so far 1 3 that we updated in the next line. The current value is right now 0 because we are looking at 0. Then I'm going to append the count into it. So the count of 0 so far is 2. So the new string becomes equal to 1 3 and then 0 2, right? And then we keep on repeating. So then we again compare the current value of 0 and 1, since so we have already done this in this step. Then we compare 1 with the next one. Okay, it matches. So we increment the count, and we keep on doing this again and again. And also every time we do this, we have to reset the count back to 1 because the values have changed. So this is the idea. So when we were counting these, there were 3 1s. But then when we encounter 0 here and we go into the else statement, so we have to set the count to 1 because we have found 1 0 so far. And then it will become 2 next time. And this will keep on happening again and again. So by the time the loop ends, we would have read all the characters except the last. And the reason is that it's the same as we do in bubble sort. We compared the second last character with the last character. So we will be running the loop n-1 times, okay? Because if we compare the last value with the next one, then it would be wrong because there is no value after this. So we have to just store the last character in the end, and that will do all the characters except the last. So we just save the last character as it is in new string. This is our algorithm that we're going to go for so far. Right? So this one will get compared here, this one will get compared with this 0, but this 0 here, it will not get compared with the next value. Since this comparison would stop here, so this 0 will get ignored. And we cannot just ignore the 0. So what we'll do is we'll pick the 0 and then we'll directly add it in the end of our string. So we're going to convert this whole logic into code. I'm just going to comment this and let's try this. So compress function. Okay, so we have the global new string. Again, they've told us to use it. It's new string and we can assign it a value. Maybe it's initially empty like this. Okay, then in the next part, we are going to read the values from the queue and we're going to store it all in the queue in another array. Okay, so all the values in the queue are there. So these values that we enqueued before using the read data function, we are just going to dequeue all these values and store them in another array just for our convenience, or you can use them in a string format as well. So I'll say, let's call it data is equal to 0, or let's call it bits. Bits is equal to empty, and then we'll just say while the number of items is greater than equal to 0, keep on dequeuing like this, and then whatever the value returns, so it will return a response. So just append that response into your bits array. So whenever we run dequeue, it is going to return us one value from the queue and then move the pointers. So I'm getting the value from the queue and I'm adding it into the bits array. This is just to make our logic simple. Again, you can use it as a string. You don't need to make another array. Okay, once the while loop ends, we have all these values, but in form of an array. So if I print the value of bits here, so again, if I call compress, we're not supposed to run this right now, but this is just for testing purposes. Okay, yes. So it's the same thing, right? So they are duplicates of each other. Okay. Now going back to the question. So now we have all the bits ready. Now what we have to do is we have to do this part. We have to compare the current value with the next one if they match and if they do not match. So for this, so compare current bit with the next one. So for this to happen, we will initially set the count to 1 because they are saying that you will assume that there will at least be one item in the queue. So count cannot start from 0. Okay, so for I in range ln of data -1. Okay, why going till -1? Because again, as I explained, we are comparing the current value with the next value, just like we do in bubble sort. So by the time we have reached the second last value, we'll compare it with the last value, but we cannot compare the last value against anything because it's not present. So we're going to check if, again, I keep writing data, this is bits. So, okay, we check if bits current value of bits is equal to the next value of bits, right? So what I'm checking is the current value 1 next equal to the next value 1? If that is the case, I'll simply increment the count by 1, right? So an example, let's say I just make the example here. So bits, this is maybe how bits look like. We have 1 1 1, then we have 0 0 like this. So what we're doing so far is we're checking, is 1 equal to 1? Yes. So I'm going to increment the count by 1. So this becomes 2 ones, then it becomes 3 ones. Simple enough. Then if that is not the case, okay, once we've reached this one here, the next value does not match. So what we're going to do is, whatever we have gotten so far, including the number and its count, which is 3, we are going to just simply append it into the new string. So I'll say new string is equal to new string plus, first of all, I'm going to get the current bit, which would right now be equal to 1. And then I'm also going to concatenate or join the count value with it. And I'm going to add the value of count here as a string. Okay, so what did I do? Again, this was an empty string. I got the current value from the bits array, which is right now set to 1. and then I'm simply adding the count of the values, which is going to be 3 so far. So this successfully becomes 1, 3. Once we have done this, we also need to set the count to 1 because we are resetting the count. So next time when we count the 0, this would be 1, 0 at this point. So this is the whole part. And if we just print the new string so far, let's see what we get when we run the function compress. Okay, it says 1 appears 9 times. Okay, let's see. In fact, for just now, we'll add a space as well, so it's easier for us to read. That's not part of the question. Okay, so it says 1 times 9 repeats 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it repeats perfectly. Then it says 0 repeats 5 times. So 0, 1, 2, 3, 4, 5. Perfect. 1 repeats 3 times, 1 repeats 3 times. And then it says 0 repeats 6 times. So 0, 1, 2, 3, 4, 5, 6. And this looks good enough. But let's say if this, instead of this 0, there was a 1 here. So if I just modify the file again, you're not supposed to do that. If I make this 1, this 0 here, and if I rerun the code, we can notice an error here. It says there is, okay, I think it works actually. So we have 1, 1 here. It appends. Okay, no, it's working fine. Wait, no problem. So yeah, this whole code is working perfectly fine, just like the question asked. So yeah, and I'll just remove the space from here because this is not part of the question, and that is pretty much the whole thing.
ठीक है सर। सर आप ये